Hello, and welcome to Unit 4, Functions. Lesson 2, Composition of Functions. This is something that is brand new to you, and we are going to talk about what we talked about last time first to kind of bring it all together. We know that function notation can be written f of x, and this is an expression given f of x equals x minus 2. What that means is that the variable within that function is an x, and the name of the function is f. So bear with me and listen carefully. We can think of this as f blob equals blob minus 2, where blob can be anything you want it to be. For example, let's replace the x, or blob, with 2. And when we do that, if you think back from the last lesson, what that means is we're replacing all of the x's with the number 2. And then we can evaluate so that 2 minus 2 equals 0. And you can do that for any value that you can think of. So for example, let's talk about f of negative 3. We replace blob with negative 3 minus 2, and that gives us negative 5. But you can replace blob with anything at all. So for example, let's replace blob, or the x value, with x minus 3. So we're going to replace the blob, or the x, with an expression instead of just a number. That means everywhere in the expression that you see blob, or the variable, which is x, put x minus 3. And then simplify that expression. So x minus 3 minus 2 makes x minus 5. We're going to carry this one step further today and do something called composition, where we replace blob with another function. The notation for that composition looks like this. We're putting a function into another function. In this case, we're going to put the f function into the g function. So the two functions that we're going to deal with are f of x equals x minus 2 and g of x equals 3x. So think of f of x as blob. Here's where our blob is, and it's equal to x minus 2. And we've got g of blob, and everywhere that you see blob, put x minus 2. Okay, so g of x, since g of x is equal to 3x, we'll replace every x with blob. So right here is where blob goes. Well, blob is x minus 2, the function f of x. So everywhere there's an x, put put x minus 2. And then simplify that expression. So 3 times x is 3x, and 3 times negative 2 is 6. Now I know that sounds pretty confusing, and there's lots of words, and what the heck does blob mean? Let's practice this a few more times. So for this example, f of x is equal to x squared plus 3, and g of x is equal to x minus 3. And what they're asking us to do is replace the function within f to be x minus 3. So basically, the way I want you to think about this is that we're putting a function into another function. So let's take the f function that looks like this. F of x equals x squared plus 3. Notice I left out the x's this time and put parentheses in their place. And within those parentheses, I'm going to put what I want that variable to be replaced with. And what I want the variable to be replaced with is g of x. And so g of x is x minus 3, and that's what I'm going to replace in both of those places, is that other function. A function within a function. And then you should simplify that expression. So f of g of x is equal to, and then the simplifying for this one, x minus 3 squared means x minus 3 times x minus 3. Don't forget that 3 on the end. And then we'll have to distribute to simplify. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Don't forget the 3 3 on the end. And then just combine like terms. So x squared, and these two are like terms, so minus 6x. These two are like terms. That's plus 12. Next example. Okay, same thing. This time we're finding f of g of x. This time our f function is negative 2x plus 3. So that's the outside function. We're going to replace its variable everywhere there's an x with some other function. And that other function happens to be g of x this time, which is x squared plus 5. So everywhere there was an x in the first equation, we're going to put x squared plus 5. And then this expression should be simplified. F of g of x is equal to, and this one just needs distributed, so negative 2 times x squared is negative 2x squared. Negative 2 times 5 is negative 10 plus 3, and then combine like terms. In the next example, we're going to use the same exact functions. So f of x is still equal to negative 2x plus 3, and g of x is still equal to x squared plus 5. But this time, we're going to find f of x. In other words, g is the outside function, and we're replacing its variable with the f function. Well, the g function is x squared plus 5, and we're going to replace its variable with the f function, which is negative 2x plus 3. So in both of those places, put negative 2x plus 3. And then we need to simplify that expression. We can do that by distributing. Again, negative 2x plus 3 squared means negative 2x plus 3 multiplied by itself. Don't forget the plus 5. Let's distribute. So negative 2x times negative 2x makes positive 4x squared. Be careful with signs. Negative 2x plus times 3 is negative 6x. 3 times negative 2x is negative 6x. 3 times 3 is 9. Don't forget the plus 5. And then combine like terms. 4x squared. These two are like terms, so negative 12x. These two are like terms, so plus 14. And so we use the same functions this time, the f of x and the g of x, except one time we found f of g of x, and the second time we found g of f of x, and they came out to be different expressions. And they're supposed to, that's fine. Let's try that one more time. Now this time, we're still using functions g and f, but the variable is different. It doesn't matter what the variable is. This time we're going to use the letter n. So in this problem, g of n is equal to n plus 5, and f of n is equal to n squared minus 3n. So let's find g of f of n. So let's take the g function on the outside, and we're going to replace its variable. Okay, so here's the g function. G of n equals n plus 5. We're going to replace its variable with the function f. Here's the function f. So everywhere there was a variable, put that function. Always remember, a function within a function. So g of n squared minus 3n, everywhere there was an n. And so g of f of x, n is equal to, and then to simplify this, we don't need the parentheses, and there are no like terms, so we're just going to write n squared minus 3n plus 5. And that's as good as it gets. Okay, now let's move down, use the same two functions, except this time we're going to find f of g of n. And so f is the outside function. F of n is equal to n squared minus 3n. And everywhere there's an n, we're going to replace it with the g function, and the g function is n plus 5. time we have to put it in two different places for the function itself. Okay, let's simplify. So f of g of n is equal to, now n plus 5 squared means n plus 5 times itself. And I'm going to go ahead and distribute this negative 3. So negative 3 times n is negative 3n, and negative 3 times 5 is negative 15. And then I'll have to distribute n plus 5 times itself. N times n is n squared. N times 5 is 5n. 5 times n is 5n. 5 times 5 is 25. We're going to put negative 3n minus 15 on the end, and then combine like terms. So we end up with n squared, and then 5n minus 3n all go together. 5 plus 5 minus 3 is 7n. And then 25 minus 15, those two things are like terms, and that gives us positive 10. Okay. Let's talk about what happens when we are finding a composition, but this time with a value. So if you notice, we're given two functions. F of x equals x cubed minus 6x squared minus 5. And g of x is equal to x plus 3. But this time, we're not finding f of g of x or g of f of x. We're finding f of g of 2. That means that g's variable is going to get replaced by 2. And then whatever we get from that, we're going to replace it into the f function. So let's take this a step at a time. Step 1, let's find g of 2, because that's what this expression is telling us to do. Find g of 2. So if we take the g function and replace its variable with 2, the answer is 5. So then we're going to take that answer, g of 2, and we're going to plug that answer into the f function. Well, the f function looks like this. X cubed minus 6x squared minus 5. And what we have to do is take what we found g of 2 to be, which was 5, and plug that into every place where the x was. So f of 5 is equal to 5 cubed minus 6 times 5 squared minus 5. 5 cubed is 125. We need to follow the order of operations. 5 squared is 25. Okay, so I evaluated the exponents. Let's do the multiply step next. So 6 times 25 is 150. Think of it in quarters. If you have 6 quarters, you've got $1.50. And then 125 minus 150 is negative 25. Minus another 5 is negative 30. And so this is what f of g of 2 is going to be for its value. We're actually plugging in numbers this time. Okay, same thing, new example. This time we're going to plug in, or we're going to find f of g of negative 2. So step 1, take negative 2 for your x value, plug it into the g function. So 3 times negative 2 minus negative 2 squared, be careful with signs, is equal to negative 6 minus negative 2 times itself is positive 4. So it's going to be negative 6 minus positive 4 is equal to negative 10. Okay, so then that answer we need to plug into the f function. F of negative 10 is equal to negative 10 minus 2. This is the f function, x minus 2. So f of g of negative 2 is equal to negative 12. Okay, that'll have to be all for now, as I have run out of time on my podcast. Thank you for listening.